Alright guys, let's jump in. I want to take off where we left off last time. I feel like a few more examples would make us feel a little better. Alright, so I'm going to do two more, and I hope they're not long, and I will not be as elaborate with the explanation. So if you're ever lost on what's happening in this video as it's being done and you don't know why, this video is targeted more towards to build your confidence. As you see it done, you should be able to predict what's being there. If you can't do that, then go back and watch the other two videos. Alright guys, we're graphing this and we need to label all this information. Again, we talked about how the first and second derivatives and the things that we need are the intercepts, asymptotes, first and second derivative sign charts. If we can find those, we can graph our function very, very cleanly and very, very clearly. Acquiring them often gives us a headache. These problems normally do not go in that specific order because they don't really give us a function. They didn't give us the original. They just give us the derivatives of them. So we can't really predict what the original would be. So we just have to go over the information that's given. So keeping that in mind, let's get started. All right, so they say for f of x, and this is probably a big thing. I need to switch colors if you guys are going to see what I'm writing. So they want us to label some things. Label the maxes, mins, intervals of increasing, decreasing, which actually means sign charts. Points of inflections, the twisting and turning. Concavity, concave up, concave down, another sign chart. And asymptotes. So those are the informations we are already looking for. All right, so here we go. And then I'll try to go back and graph this thing. F of x is defined for real values except x equals 3. So what they're telling you is that x equals 3 is not defined. But it doesn't know what to do. Now that could mean there's a vertical asymptote there. Or it could mean it's a little pothole like that there. Alright, so it could be something like this, or something like that. But keep that in your head. These two I need for the sign charts. I can already tell you that already. The sign charts of f prime and f double prime. The line x equals 3 is a vertical asymptote. Well, thank you. You're very nice. Now if you start playing Inspector Gadget, didn't they just tell you that x can't equal -3, and we said it was either a whole or vertical asymptote? So really, this is proof that it's a vertical asymptote. That's a big deal at x equals 3. All right, so now it confirms it. They're telling us as I approach infinity, well, there's no horizontal asymptote because this goes to infinity. So this is no horizontal asymptote. Okay, so those are the easy ones. This guy is going to be a little bit of the pain in the neck. Why would I put that in there and it doesn't factor like that? Oh, what a disaster. Alrighty, so if we do the sign chart on this, okay, and maybe I'm not cutting myself enough space, but this is the idea. Okay, at 3, we're going to have an undefined. So at f prime of x is undefined at x equals 3. And f prime of x is equal to 0 where? Well, I don't know because I think I need to use quadratic formula on that. Can I do that in my head? X squared minus 2 plus 1 minus 1 is 5, which means x minus 1 does not, so it has none. Alright, so this guy has no x-intercepts. It only has an undefined. So undefined will definitely be on my axes. Let's nail this one, f double prime of x. Okay, well, here's a sign chart, and I think this one we can look through it pretty easily. X equals 3, 0, and 6. And of course, we'll go back and we'll label things accordingly. We already know there's a vertical asymptote at 3, so I don't know why we just don't adopt it already. But we always need to look at it as, oh, it's just not differentiable at that point. That's what because it gives us the thought that it could be other things. So this is f prime, this is f double prime. All right. So these are undefined, right? Because they're not differentiable. These are zeros. And now we just need to find the signs of everything, okay? So to the left of 3, I'm going to go back to the original derivative. If you go, say, 100, it will be positive and negative. Okay, so that's one. And the other one here, let's see here, f double prime is what? If we go left really big is positive, and then I'm pretty sure this is negative, negative, positive. All right, so that's just using multiplicities. And what is the whole point of what I'm doing here? If I don't do those sign charts, and I can't get the real sign chart I want, which the real sign chart is on f. Whoops, on, man. I was trying to save that one for later. Jeez, oh pizza. Which is really this guy. F, which is going to consume all of these, and we have to label these zeros and undefineds accordingly on here. But I always like to go through left or right and choose one function at a time. So looking at the normal derivative, I know that on the left of 3, it is decreasing, increasing, right? And then from the second derivative, I know in between this guy would make it concave up because it's positive, concave down, concave up. And then I need to label what these actual points are by thinking about how they land together. Right? So a lot of this is just massive investigations. So at 0, it's a inflection point. It's a twisting point. Okay? This other 0 is also an inflection point. The 0 here is a critical number, so the question now is it a maximum or a minimum, or is it neither? It goes from decreasing to increasing, so it's got to bottom out, so it's got to be a minimum. All right, so that's the sign chart I need to actually graph this guy. So after I get this out of there, I don't need any of this anymore. Really, I don't. And I'm going to try to put the graph right here so it just lines up perfectly with the work we've done. Because we did all this work. That stuff is to get my sign chart. I'm going to put back the 3 here for the vertical asymptote. So I'm still going to look at this information that they gave me. All right, just to make sure. But these two informations was all the information I just erased. All right, so now let's graph it. And as I put stuff on the graph, I'll start erasing them. All right, so the first piece is x equals 3, because I need the space, obviously. That's my vertical asymptote, which I'll put here. Let's get rid of that. Boom and boom. And boom, and boom, and boom, and boom. Okay, so I did this, check, and check. We use these already to create that beautiful sign chart that's down there. We'll look at that later. And then there's no horizontal asymptote, but I do know when it should go up as it goes to positive infinity, go this way, and that should go down that way as it goes to negative infinity. All right, so this is all taken care of. So the only thing I need left to do now is just read my sign chart and throw that information up there, and I have how my graph looks. Alrighty, so at 0, we say there's an inflection point, so it's turning, right? So let's see if I can go about graphing this. Starting from the left and down, it's decreasing, concave up. That makes no sense. Oh, crap. It's because my sign chart was backwards. This should be positive, positive, so it'd be increasing, increasing, decreasing, decreasing. My goodness. Increasing, increasing, decreasing, decreasing. Thanks, guys, for catching that. All right, so as it goes from negative infinity to 0, it's increasing concave down until it gets to 0. So I'm going to put this first line in blue so you can see how it's going in. So I'm increasing from down here forever because there's no horizontal asymptote. I'm increasing concave down until I get to 0. Now, I don't know where 0 is, and that's why you need to find these inflection points. So if I plug 0 into the regular function, I would be able to find where that is. But I can't do it now because they didn't give me the original function. So I'm just going to say it's right here because that's where I feel like putting it. Okay. Now, I know I have a minimum at 3, though. Not a minimum, but a vertical asymptote at 3 minimum. What is wrong with me? Vertical asymptote at 3, so that's here, but in between 0 and 3, it's increasing concave down. So it's increasing concave, it's increasing concave up before. Sorry, guys, there we go again. Concave up holds water, then it turns, and that's why it's an inflection point, and then it increases concave down forever. Okay, now, and here's a crazy part. It looks weird because you think like, oh, it's going to run into the asymptote, but maybe it just increases ever so slightly, so it can do that forever, and that's kind of the whole point behind it. It always seems kind of tricky when things inflect like this. You're like, what is that? But no, that's really what's going on here. It's doing one of these. It's getting close to that asymptote very slowly, and then it's decreasing, so it has to come from concave down, so it's doing one of these, decreasing concave down. From 3 to 6, which I'll call this 6, to wherever that is. Remember, it doesn't have to cross the axes because these are just what's going on with the slopes and whatnot. slopes and concavity. So it's now, when I get to 6, it should decrease concave up. I am not doing well with this concave up, concave down stuff, guys. Let's try this one more time. Decreasing concave down. So let's do one of these. So it gets to 6, and then it starts decreasing concave up. So I don't know exactly where this would be. Normally you would find your inflection point to know what this point was. So you'll know how hard to start cutting your line when you draw it. But this is as close as it's going to get to being perfect. And guys, just remind yourself, I've been at this for about probably 11 hours. Concave down looks like that. Concave up looks like that. Concave down looks like that. Concave up looks like that. Right? Now, if it's increasing, that means it's got to increase. So shift it upwards. And if it's decreasing, it's got to stay like that. So that lets me know how it should look. I'm just putting those pieces together. So you notice this piece is this piece. This piece needed to be flipped up. It's increasing, should look like that. So that's this piece. This piece is decreasing concave down, so it should be going down like that. That's this piece until you get to 6. And then eventually it turns and then starts to go concave up. So I ran out of space, but that's effectively what it is. All right, guys. This is pretty much it, but the next example is really the one that's going to take the cake. So here we go. This is the graph of f prime, okay? Your job is to, if you know how at least, if you know f of 0 is 0, okay, sketch f. Okay, so this is where it gets fun. Did I draw it on the other paper? Yeah, I think so. Okay, so here we go. This is what we're going to do. I'm going to make my make an attempt to make a sign chart of f. Okay, all right, so look at all the big things. Now remember, this is f prime, so this x-intercept means that f prime of, when you plug 2 in f prime, it's a 0. That's a horizontal tangent, as well as this guy. That's a horizontal tangent on the regular function. So if I had to tell you stuff, so this is what you got to pay attention to, is that the connections of things are very important. So if this is a horizontal tangent, then wherever it is on 2, like if it was there, that would be a horizontal line. And at 6, I don't know, wherever it could be at the same place. It's a horizontal tangent. I don't know. Okay, bottom line is though, the slope is going to be 0. All right, so when do your slopes start changing from negative to positive? So you got to ask yourselves that. Well, these slopes are all negative because they're below here, right? So it lets me know that we're decreasing from 0 to negative 2. So maybe what I'll do is just make the sign chart instead of trying to play with this graph. So here's a sign chart of f. It's 0, it's 2, it's 6. To the left of 2, it stops off at 0, so don't think you can go further than 0, and it's not going to include 0. I know it's an open circle. Those are negative slopes. It has a horizontal tangent here. And then 2 to 6 is positive slopes, and then you got 6 on up, right? Now, f double prime you can figure out. You're like, Rush, well, how can you figure out f double prime? Well, isn't f double prime the derivative of f prime? And what does the derivative of any function tell you? The slopes of that function, right? So, if I want to figure out what's going on with f double prime, all I got to do is look at the slopes of f prime. So, this guy is where a slope is 0. So, that's at 1. This guy looks like where the slope is 0. That's at 3. And this guy looks like where the slope's at 0. That looks like 4. Okay, and don't forget the 6 has got to be on the other side. But those things, now let me look at it. Now let's look at the slopes. To the left of 1, those are negative slopes, it looks like to me. To the right of 1, those are positive slopes. 1 to 3. And then from 3 to 4, those look like positive slopes as well. And then from 4 to wherever, those all look like negative slopes. Okay? So this gives me enough. I don't have any points on the original graph except for the previous information. They say it started at 0, 0. So here we go. This is what f should look like. So I pulled out all the info. And notice all of these, the only ones I know is that these are horizontal tangents. And then these points here, these 0 points that are here, these are inflection points. because they're not undefined. So we're all pretty good to go. All right. So I'm going to try to blow this up. We have it starting at 0. Maybe I might really blow up this number line because it's just really too small. It's hurting my eyes. And if it's hurting my eyes, it's probably hurting your eyes. All right. So we have 0, 1. All the numbers that's up there, put them down here. 2, 3, 4, and 6. And then we're going to try to go through and label. Let's just start with things that are the first derivative. Left of 2 is going to be negative, which means it is decreasing. So it's decreasing here and decreasing here. And again, it starts at 0, right? It starts at 0. We can't talk about anything on the left of 0. In between 2 and 6, though, that seems to be increasing. And then to the right of 6, it's negative, so it's decreasing. Okay? Now, let's look at the information to look at its concavity. To the left of 1, it's negative. When this negative lets me know that it is going to be concave down. All right? In between 1 and 3, that thing is going to be concave up. In between 3 and 4, it is also concave up. And in between 4 and 6, well, that's just 4 and everything. It's all going to be concave down for the rest of the problem. Okay? So now label your inflection points. This is an inflection point. 3 is an inflection point. 1 is an inflection point. And 2 is for sure 0. Is a horizontal tangent. So going from decreasing to increasing, it's got to be a minimum. And then likewise, increasing to decreasing, that's got to be a maximum. So now we have everything labeled to graph F. See, so you really don't need a whole lot of information. I mean, you really don't. We just need a whole lot of detail from that information, which is a pain in the butt sometimes. All right, let's try to graph this. I think I'm out of paper, so yep, I'm out of paper. So therefore, we're going to have to go through this and do it on this sheet. Now, you're probably saying, Resh, it seems like you're going to crush it all in here. Nope, watch this. Okay, starting at 0, 0, because that's what they told me. They told me to start at 0, 0. Now, to the left of 0, I want to go concave down, decreasing until 1. So I'm going to label my point 1, 2, 3, 4, 5, 6, and that's it. Okay? So I am decreasing concave down, and it's an inflection point. So I'm decreasing concave down. Concave, that's concave up. Why do I always do that? Tricky. Decreasing concave down until I get to 1. So I'm going to make it like right here. Okay? And then decreasing concave up until I get to 2. So I'm still going downward until I get to 2. All right. And then it should be a minimum. So that should be a bouncing point. So now I start increasing concave up until I get to 3. And that's an inflection point. So it should be a spot where it goes from being concave up to concave down. All right. And then at 3, it's increasing concave up until I get to 4, so I'm increasing concave up. It's always a tricky one. Tricky. So it goes tangent and then increases concave up. Okay, until I get to 4, and then at 4, it's increasing concave down. Why is this thing inflecting so much? It is not that fancy. And then finally, it gets to 6, which is decreasing concave down, decreasing concave down. And it does that forever. So effectively, this is the graph of the original graph. Okay, it all comes based off of that first sign chart that we make. All right, guys, it's been an extremely long last 3 videos. I would encourage you to watch them multiple times. There's a lot of detail in there. And then creating the actual sign chart for F off of the first derivative and second derivatives are a taxing ideal. So work hard, keep doing all the good things, and I'll see you guys on the next videos. We start anti-differentiation integration. Bye.